Okay guys, in one of my video that is related to anchor bolt, okay, so one of you have asked me that if the base is pinned, okay, and the upper frame is moment connected, then how does the flange carry loads from column to the base plate? Okay, so basically he is asking that, let's say this is the portal frame, okay, and the base is pinned, but this is moment connection, and let's say you have some load like this, okay, and we are using some I section for this column, and we have a pin base, and in actual cases it looks something like this. This is the plan view of the column, and let's say this is the pedestal, and your bolts are placed here. So how this connection actually carry the moment that is generated here from column to the base? Okay, so if you are new to this channel, please do subscribe, and also don't forget to press the bell icon so that in future you can be benefited. Okay, so let's start. So today I will try to explain this question just in a simply whiteboard analysis. Okay, so we have three type of portal frame. Let's say first one is this one. Okay, and here everything is pin connected, everything. Okay, so if you have a lateral load like this, what will happen? So if let's say you have any object and you simply put some load or force, what is the inevitable situation that will arise from this case? Simply there will be some displacement. Okay, so due to this force you will have some displacement. Now let's say you are trying to resist, or you are trying to restrain this displacement. You don't want any type of displacement. Now you are applying some force. What will happen? Well, as there is no displacement, or you are actually resisting the displacement, you will generate some stress here, and if you simply multiply this stress with the area, you will get some force that is actually acting in opposite to the applied force, right? This is also valid for any moment. Okay, so let's say you have a member like this is pinned. Okay, now you are applying some load here. So what will happen? Simply it will topple, as there is no resistance against rotation. Now let's say you are not interested to have this rotation. So what will happen? So you have to put some fixity here. Now you are applying some lateral load here. Now you have resisted this theta. Now your theta is 0. So what will happen? You will generate some moment, or you can say you will generate some stress related to this moment. Okay, now come to the actual question. So here in the very first case, all the joints are pin joint. Okay, so that means you are having a rotation here. Okay, you are allowing a rotation here. Okay, also as these are pin joint, let's say you have two members. Now they are pinned connected. So what will happen? You can have infinite number of shapes like this, like this, like this. Okay, why? Because you allow a rotation here. Okay, as a result, what will happen? Once you apply a load, okay, due to infinite number of combination, this will simply collapse like this. Okay, this will simply collapse. Why? Because you are allowing infinite number of combination in these joints. Okay, these are base pinned, but in this connection here you are allowing infinite number of combination here also and here also. Okay, now to make it stable, what you have to do? You have to either resist the rotation here or here or everywhere. So if you resist everywhere, at the base first, then at this junction of beam and column, then it becomes a fixed portal frame. Okay, and if you only resist at this beam column junction, okay, but not at the base, then this becomes a portal frame with pinned base, okay, and this is the case of our discussion, right? So now you will have resistance here at the beam column junction, but you are allowing the rotation at the base. You are allowing rotation, okay. So now I have a frame where the base are pinned, but the beam column junctions are moment connected. So now let's say you have a lateral load like this. So how it will deflect? From base, if we consider, it is very simple, because at the base we are not restraining any rotation, so it will rotate like this. It will have some rotation. Let's say this is theta, okay. So it will have some rotation. Just simply project this up to the top tire. Now what will happen here in this joint and in this joint? Remember, in case of a pinned joint, let's say these are two member, you may have infinite number of combination. But let's say you have a beam column junction where this is moment connected, okay, in that case you will have only one combination and this angle will remain same. In this case, let's say this is 90 degree, okay. So the angle will remain same. That is why it is stable. Though the bases are pinned, as this angle remains same, it is a stable structure, okay. So here you will have a 90 degree angle like this, and here also you will have a 90 degree angle like this. So like this you will have to shape your beam, okay. So this is the shape of your beam. Why the shape of the beam is like this under deformed condition due to this lateral load? Because it have to maintain this angle, okay. Why? Because this angle or this junction is a moment connection, okay. So now it is clear to you how this joint and how this joint will behave. So from this deformed shape you can draw the bending moment diagram very clearly. So here, due to this beam, you will have a bending moment diagram like this, okay, because we have a point of inflection here where the bending moment will be 0, and in the column the bending moment will be like this. Here this is the bending moment at the face, okay, in this side, and here the bending moment will be inside, okay. Now the bending moment at this base is how much? 0. Why? Because you are allowing the rotation. The theta is not 0. That is why you will not have any stress here, and once you do not produce any stress, you will not have any bending moment. That is why here you will have 0 bending moment. The same is true for this column also. Clear? So this is the bending moment diagram. So once you reach to the base of the column, you have a bending moment equals to 0. Now tell me, do we need to provide any bolt outside of the flange? We do not need. Why? Because there is no bending moment. So as there is no bending moment, there is no push and pull, okay. Tension and compression is 0, and you know the flanges carry the tension and compression, but in this case we do not have that. So we do not need any fixed base. The pinned base is enough. This is the reason we provide the pinned base, because in case of a pinned base the moment is 0. That is why the size and the reinforcement requirement for the foundation is much less. That is why it is economical. But once it become economical, you have to compromise with the lateral deflection. You have to remind this. Once the deflection criteria arise, if you have a very strict deflection criteria, in that case you must have to provide the fixed base so that this theta become less or almost 0. Okay, hope you enjoyed this video, and if you like, don't forget to share it.